Hello guys, this is Shashikant and I am back with a topic on isoelectric point. Let us understand the meaning of isoelectric point. Isoelectric is made up of two terms, iso and electric. Iso means equal, electric means charges. So in this context, isoelectric means the equal amount of positive and negative charges. In another words, so isoelectric point is the pH at which a molecule has equal amount of positive and negative charges. Let us calculate the value of pi of a given protein. I hope you guys can see the question on the screen. Let me read the question for you. Calculate the pi of the peptide ADGAVI. Show diagrams and calculation explaining how you reached this conclusion to get your marks. Use the table at the end for pKa values. In this question, we have been given with a peptide that is ADGAVI. A stands for alanine, D stands for aspartic acid, G stands for glycine, A stands for alanine, V stands for valine, and I stands for isoleucine. At the end of the question, we have been given with a table that shows the pKa value of different groups present in the amino acid. In the first column, the amino acids are arranged in alphabetical order. In the second column, we have been given with the acronyms for the respective amino acids. In the third column, we have been given with the pKa value of the alpha carboxylic group that is attached to the alpha carbon of the respective amino acids. In the fourth column, we have been given with the pKa value of the alpha amino group that is attached with the alpha carbon of the respective amino acids. In the fifth column, we have been given with the pKa value of the side chain of the respective amino acids. And we should be careful that all the amino acid doesn't have the side chain, only few amino acids have side chain. I hope you guys have understood the question. Let us start solving the question. The first step is to draw the structure of the peptide given in the question. And make sure that the structure should be drawn at pH 1. Therefore, most of the functional group of the peptide should be in protonated state. Like you can see, the amino group of the alanine is protonated, the carboxylic group of the aspartic acid is also protonated, and the carboxylic group of the isoleucine is also protonated. And since there are only 3 ionizable groups, that's why we are more concerned about only these 3 residues. Rest of the residue doesn't have any ionizable group, so they will not play any role in calculation of the isoelectric point of the peptide. In second step, we calculate the overall charges on the peptide at pH 1. Since we have drawn the group, the structure of the peptide at pH 1, therefore it is easy to see that there is only one positive charge on the amino group of the alanine. Therefore, the overall charge on this peptide is +1. In the step 3, we increase the pH of the solution such that the overall charge of the peptide becomes 0. And we note down the pKa of the charged group just before and after the peptide become neutral. Once again, at pH 1, the amino group of the alanine residue is already protonated, thus it acquires a positive charge. Therefore, the overall charge on the peptide at pH 1 is +1. When we increase the pH of the solution to 2.4, the carboxylic group of the isoleucine residue loses the proton, because 2.4 is the pKa of the carboxylic group of the isoleucine. Thus, the carboxylic group acquires a negative charge. Therefore, the overall charge on the peptide becomes 0. Next, we increase the pH of the solution to 3.9. That is the pKa value of the carboxylic group of the R group of the aspartic acid. Thus, the aspartic acid loses the proton and it acquires a negative charge. Therefore, the overall charge of the peptide becomes -1. For example, if we want to calculate the pKa of the alpha carboxylic acid group of the alanine, we would look at the table somewhere here, that is 2.3. And if we want to find out the pKa value of the R group of the aspartic acid, we have to find the aspartic acid. I think we have found it. So this is the aspartic acid, and the pKa of the R group, that is carboxylic group of the aspartic acid, is 3.9. So this is how we find out the pKa values of different groups of the amino acid. In step 4, we find out the pi of the peptide. The pi of the peptide is the average of the pKa group that ionized just before and after the peptide become neutral. In another word, the pi of the given peptide is pKa of the carboxylic group of the isoleucine plus pKa of the R group of the aspartic acid overall divided by 2. This is equal to 2.4 plus 3.9 overall divided by 2, which is equal to 3.15. Therefore, the isoelectric point or isoelectric pH or pi of the given peptide is 3.14. I hope you guys have understood how to calculate the pi of the peptide. If you guys have any queries, please let me know in the comment section below. I will do my best to answer all your questions. Thank you to all of you for watching this video. I wish you all the best.